And thanks for joining us today. I will be talking indeed about event data modeling in cloud data warehouses. Let me share my screen with you. There we go. So why am I talking about this topic? As Oksana said, I am on the solutions architect team, and I have a lot of companies with setting up their data models, and actually throughout their whole data journey. And what I see a lot is that people sort of overlook data modeling because I guess it's not the sexiest topic to talk about. I mean, it's not AI, it's not machine learning. Um, it's mainly SQL based modeling, but it is very important to have a look at. And today I hope to show you why this is important and how you can get started with this yourself. So what am I going to talk about today? I want to start with two more theoretical parts about what is data modeling. I want to go through some definitions just so we're all on the same page with what everything means, as well as some business logic surrounding data modeling. Um, then I want to go into why would you do your own data modeling versus using package solutions. We'll go into the benefits and some use cases there might be for this topic. And lastly, and that's going to be the biggest part of this is a more practical um, discussion around how do you get started with data modeling. So what business requirements are there, and what data concepts can you think about? And that will be the main focus for today. And what I want you to take away today is apart from how important data modeling is and then how perfectly easy it can be to set up, uh, I want you to think about critical thinking in your business as well. Why do you do what you do, especially when it comes to your data and the things you track and the things you model? What does that mean? And what does it mean in general? What does it mean to you? And what does it mean to your specific business or your specific use case? Because that's one of the main strengths of data modeling in cloud data warehouses. Um, if you do have questions, please let me know. There is a questions box in the console here, so there will be time to ask some questions at the end as well. But with that, so let's dive into what is data modeling. And I'll throughout the presentation will be using this definition. So we say that data modeling is the process of using business logic to aggregate or otherwise transform raw data. Well, that's quite a mouthful. Let me demonstrate what I mean. So you as a business have probably have a lot of raw data. You set up your trackers in your website or your app or um, maybe your backend even, and all this data comes into one big table in your data warehouse, um, and it's all raw and not very usable. So for different teams and different analysts to actually use this data, you'll need to transform that into model tables. So maybe you have a website and it's very important to you what happens around page views versus on mobile where you might look at screen views. There's a lot of companies out there who make decisions based on defined user sessions. And even going further into that, user tables with all the information regarding a user, like are they a subscriber? Do we know for an e-commerce company, for example, are they a big spender or do they have seasonal uh, things they look at, all sorts of things that we might not get from the raw data right away, but if we transform it into usable tables, we can do a whole lot with that. Um, and for many companies, this is a relatively new concept. Um, and why is that? That is because there are perfectly viable traditional package analytics solutions out there that don't require companies to develop their own data models. So you have your event sources here. So you have your trackers in like I said, your app or on your web page. And you have your reports and whatever happens between that is there's magic. So you get your numbers out, but where they actually come from and what they might mean is not something you have control over. So we do see a trend towards assembling your own data stack, and that does require looking at that middle step. There's no more magic. You actually have to do something. So the process is still similar. You have your event sources again, and you have your reports and your visualization tools. But this piece, this data modeling piece, is it's where the magic happens. But you have to make the magic happen yourself. And like I said earlier, this is not a very sexy topic that's talked about a lot. Like it's not AI, it's not machine learning, and most data modeling we do is in SQL, which might also not sound as cool as Python or Julia. But if you can do this part, if you know your basics, if you know your data is correct, you know what your data means and where it comes from and what you do to it, then these reports here become so much more clear and will give you so much more knowledge about what's going on. And even if from that data you want to go into machine learning or AI, that will be so much more powerful if what happens here transforms it in the way that you need it as a business or as a business case. So as a company, why would you do data modeling? There's, like I said, there's solutions out there that do it in sort of magic box out there for you. So why would you do it yourself? Well, there's definite benefits of defining and building your own data model. Like I said, the data is available in a structure that is relevant to whoever consumes the data and the use case. Because in that data model that you write, you have to write it yourself. So you can also make it in a way that works for whoever needs it. The tables we just looked at, like a user table, for an e-commerce company, a user table looks completely different from maybe a job site. Just because there's different information available and the user itself is a very different user with its own user journey. Which also leads into that data can be explored at a high level or in great detail, again, depending on the requirements. We'll look a little bit at sessions and sessionization later on. If you are a media company that serves 3-hour documentaries, then a session might look very different from looking like Twitter, for example, where people just scroll through for a couple minutes. So in having your own data model, you can be as granular as you need to be. And you can self-serve rather than relying on analysts. Like if we have those specific tables where the specific information is in there that they need, they can go in, do their own queries, and are not dependent on any bottlenecks there might be. As well as lastly, all teams in your company, if you have a good data model, that will use a common data source, and that makes sure that there is consistency and trust in the data across the organization. So occasionally we will see that there's marketing teams using tool A, and then you have your product team using tool B. They both can do their analysis on there, and they get their reports out of there. But with two solutions where you might not completely have insight into what is going on with your data and where your data is coming from and the transformation it goes through, you might have a discrepancy there between what both teams see. So if both teams use the same data source with their own tables still, but made from that data source with insight in what happened there, you get much more actionable insights, and you get more decisions across the business being informed by data. Let me demonstrate this though. So assume you want to understand the performance of marketing content on your website. And for that purpose, we'll look at this user journey. So we have a user that lands through an organic search on our homepage. They will then find the blog, read a couple of articles, and then request a demo as a measure of conversion. So So if we look at sessions, you might get the following information from this journey. So we have a session start here. We have a session ID, marketing channel. Like I said, it was an organic search. We know they visited 5 different pages, and we know that the session length was 2800 seconds. And we do know that there is a conversion out of this session. If we then look at a couple of different sessions that happened during a given moment of time, this is what your data might look like. So different sessions, different channels. We can look at page views, different session lengths, and whether or not something converted. And there's a couple of calculations we could do there to see if there's any influence on conversions. So if we look at our page views as well as your session length, we calculate an average session length per page view. We get a couple of numbers out here. And if we then look at if there was a conversion there, you see that there seems to be some influence to the average session length on conversion, which is great. Because if you're a marketing manager responsible for content, you can see that the content engagement and the conversions relate. So you got something going there. It does, however, not give you any actionable insights. You might have a lot of questions surrounding this, like how much time in a session is spent on reading articles, and which articles do users spend most time reading. That could be, especially if the average time is important, something you want to know. And are those specific articles that are read longer the ones that lead to conversions, or do people just spend more time there but don't they convert? And you might even want to know if there is a magic length for your articles. Do people scroll? Do people just look at the titles and go on? And maybe even which topics are most interesting to new users. Now imagine that we have that same data set, but we aggregated that or we modeled it into one row per article. So we have the same 3 articles here that our user looked at. We have the authors, the date published. You can see some are published in 2020 and there's one in 2019. The total sessions these were part of, total page views, the average time a user was engaged, the average scroll depth, and the conversions that happened after reading. So if we look at the bottom one, we see that it's the oldest article with the most number of sessions and the most number of page views, which makes sense if it's the oldest one. But if we then look at the second article, which has been there much more recently, but the average time engaged is a lot higher, and the average scroll depth is a lot higher as well. So if we do our calculations here, seeing that both of them have the same number of conversions, we can actually see that this second article is responsible for a higher percentage in conversions than the other one. So this gives us the answers to a couple of the questions we just asked. Yeah, so like I said, the number of sessions and conversions are related to how long ago an article was published. It leads itself really, but also the time engaged and the scroll depth seem to be the best indicator of a conversion rate. And from this, you actually can get some recommended actions. So you can, with this knowledge over all your articles on your site, organize your content based on an engagement like time and scroll depth. Push those articles forward that lead to a high number of conversions. And you can also instruct fellow coworkers or fellow of your marketing coworkers to write more content similar to what already has a high engagement on similar topics or just adjacent topics, because you know that the users on your site who do convert are interested in these kind of topics, so they might have their own problems there, which your solution can solve. So what are the benefits of defining and building your own data model? Because it is fairly easy to just get a solution in there that does everything for you, and making your own data model, it requires time, it requires effort, it does require a certain number of skills. So why would you do that? Well, I hope you can see that data is available in a structure that is relevant to the consumer and its use case. Can be explored at a higher level of detail, like we just looked at for the articles. Again, the marketing team could self-serve, and they would still use the same data source. So why would a company make this switch? First thing we usually see what companies that come to is that your organization is becoming more and more sophisticated with data, meaning that you'll begin to see greater uses for the data. And modeling this data will democratize it and make it easier for non-data scientists and analysts to query. Secondly, as you see, you can build your own custom attribution models, your own dashboards that will reflect your business reality. It's not what an external vendor might think is important for your industry. It's what you think is important, because your business might belong to a certain industry. You might be an e-commerce business, but you're probably not in everything the same as all your other competitors out there. You have something that makes you unique, either in product or the way you present yourself. So you want your own custom models there. And we also see a lot of companies that want to shape their company as a data-first organization. And in order to really do that, you need to put your data first. So you need to own the data. You need to see where it comes in. You need to know what's happened to it, make decisions on what you want to happen to it, and then you can make your decisions based on what comes out of your analytics. Same with companies who want to take ownership. It's a big one we see. So take ownership across data sources and use it to empower your teams across your organization to self-serve their own relevant reporting and data visualizations. Because most teams are way more willing to use data and to spend time analyzing and reporting if they actually have a say in something that matters, if they know that the tables they have available to them are made for them and that the information in there is relevant, rather than being served some sort of visualization where they can't customize what they need. And lastly, we see that business can answer their business questions a lot faster without involving extensive data engineering work if you have modeled your big granular atomic data into the model tables we saw earlier. So I spent a bit talking about theory, about different concepts, but I want to get a little more practical as well to how you get started. And like I said earlier, there's a lot of things you can consider. There's a lot of concepts to think about. I think the most important one is critical thinking, because you're about to make a step from a package solutions where you were served data where you had no input in what happened to that data, to making a change to writing your own logic. And for that, you need to think about your own logic, like what is important to my business, and is the data I'm collecting, is that what I need? Does that answer the questions I have? And even the other way around, are there questions I have that I'm not tracking right now? So if you're going to make this step, it requires a lot of critical thinking, and it's good to not get stuck into, well, we've always done it this way. Because if you just do what you've always did, then you might as well go with a prepackaged solution, because that's what you've always done. Now, this is the time to get started, to do your own thing, to make the data your own, and make it work for your own use cases. So yeah, set your business logic is a first one, not just with critical thinking, but also understand what happens in your business, because you are the expert on that, as well as other teams you have in there. So if you go for this solution, um, what do you need to be in your raw data, and which models tables do you need? Which model tables can you make that will really serve the teams that need it? So you're there, and there's a couple things you can do. In my experience, the most successful data teams of all sizes, they succeed when data centralization project includes centralized business logic upfront. So you ensure that you have defined key metrics, such as sessions, conversions, time spent, the best way for your business model. Like a conversion in an e-commerce example, that might simply be someone bought a product, but you can look at subscriptions as well. For a job website, it might be an application, or is it when someone has successfully gotten a job? So those are things you want to think about. So what are your key metrics, and what do they mean for you? What do they mean in like a wider business standpoint, and what does it mean in your individual teams? So sometimes I hear people say that defining business logic in advance and based on your specific needs might seem like an extra and a necessary step when you have these existing analytics products. Um, and those still may work for companies whose customer journeys are fairly standard, but for a large number of businesses, there are complexities that make flexible and self-determined data model preferable. For example, if you consider a two-sided marketplace like a recruitment website that has recruiters, has job seekers, they're both using the site and they're using it at the same time, but those two are exhibiting two very different sets of behavior, and they have definitely different user journeys. So designing your own data models and employing your own data modeling techniques can propel advanced analytics insights in a way that a prepackaged solution might not. So the business logic process is followed by setting data modeling concepts into motion to put together with powerful data visualization tools, and pulling data from a variety of sources, such as web, mobile, but also server, email, or any third-party data you might have. And giving these sources structure and consistency leads to a completeness of data that is essentially for data modeling. So if you are a company that has a website, but you also have an app, the data is not that different there. Sure, people might do some different things and you have some different metrics, but all in all, you're still looking at your customers and your user journey. And if you can apply the same logic to what you do on web versus what you do in mobile, that tells you so much more than looking at these things siloed and giving the mobile team their data and giving the web team their data. If you can combine that, you can see much easier see patterns, um, and also learn from what's going on both sides. So yes, centralize your logic upfront, define your key metrics, define what they mean to you and to your business, and define the user journey that your users take, and definitely go into the different users you might have. So with all of the theory out of the way, let's go into some data modeling examples. And I want to look at 4 examples here. To look at modeling macro events from micro events, I want to look at modeling workflows, like funnels or etc. Do want to look at modeling sessions, and lastly, I want to look at modeling users and their behavior. So modeling macro events. Macro events are made up of micro events. For example, if we are a media company, we might want to understand how individual users interact with individual items of video content. So if we look at the example over here, we've modeled an event stream that describes all the micro interactions that a user has with a particular video. We made it into a summary table. So we have the user one that plays video A from the beginning. They watch 10 seconds of it, pause, maybe something else. Then they watch the same video for another 20 seconds, pause, do something else. Then complete watching the video, and after they've seen everything, they decide to share it on Facebook. So if we model that data to here on the right, we see the user, the video, the number of views, time engaged, the percentage they watch, and if they share it or not. And there's much more we can add after that. But most notably, what this table includes is information about the viewer, like the user ID, which means that we can easily compare consumption patterns between different users or different user types. Maybe we know the age of this user, or we know what kind of subscription this user might have, which we can then use for recommendations or even upselling different services there might be out there. Next to the user information, we also have information about the video, the video ID over here, which, just like having the user ID, means that we can compare consumption patterns along different video types. So we know which videos are watched, how much are they watched, do people use or watch everything in one go? Do they actually watch everything, or do they just drop off after 30 seconds? Which makes us notice important patterns. We could have viral videos, but people only watch the first 10 seconds. That might be very valuable information for any advertisers we might have. Or we have more in-depth documentaries that are an hour long that people watch for a little bit, then decide to put it away for a moment and watch it at a later time when they have the time to truly consume what's in there. So that's how you can see your different patterns from models like these. And lastly, what you can see here as well is the information summarizing the user video interaction. So like I just said, have they completed the user video, and if they shared the video, which can be very important for marketing or again advertising. And as you can see, the summary table is much easier to consume than the event schema here. We can perform simply some group by or aggregation functions on it to compare viewing figures or engagement rates by user types and video types. So if I take this summary and give it to my marketing team or to my product team, they can use this information readily, almost without having to do much there. So that can be good if you have concepts like that on your website. Another one, a very important one, is modeling workflows or units of work. This can be a sign-up funnel or purchase funnel, whatever kind of funnel you have on your website. Because we see that often people are interested in understanding the sequence of events that represent the way user interacts with a particular workflow or works towards a defined goal, like an e-commerce conversion would be a funnel as well. But the example here is a user interacting with a travel site. So we have a user searching for flights to Denver. They are served a number of results. They select the first result, not what they're looking for. Then they go back to the search results. They select the second result, that is what they're looking for. They click some sort of buy button, are presented with the payment page, and they submit their payment. And again, we summarize this here in a model table. So we have, again, the user with the user ID, we have destination, all sorts of other information that might be relevant to our specific use case. The number of search results they were served, did they buy something, and what provider did they select. So our summary table aggregates the event level data to an individual workflow level, and each workflow represents the journey that starts with a user performing a search, and that ends when a user they either make a purchase of one of the search results, Maybe they'll perform another search, maybe a nearby airport, or maybe the weather in Denver isn't as great right now. Or maybe they'll drop out altogether. Maybe they were just looking or comparing, or they found something better at a competitor. So our aggregated data table, it contains a lot of interesting data already. It's data about the initial search that was performed, and it's something that will be fetched from the early events in the flow. Then you have data about the actual results that the user interacted with, which results were selected, where were they ranked, etc. And which result, if any, the user selected and went in to buy. And this data will be taken from events later in the workflow. Now, again, you can note how the model data should be easy to work with. We can compare the number of searches to different destinations. We can compare the conversion rates per destination, and we can explore whether higher ranking results are more likely to be selected than purchased. We can see how that varies by user type, by location, and whatever other key data points we might have. That is a very specific example of something with an end where something is bought, possibly. But similar logic can be applied to maybe signing in for a service or signing in for a website, and downloading an app and maybe filling out user information there. So modeling workflows is all about having a specific function or specific end goal in mind, where different teams or different analysts want to know how people achieve that end goal. And this can be a very powerful tool if, as I stated in the beginning, you have sat down and thought about what these things mean to you. What is a conversion? Is it, like here, a pretty clear point? You would buy something, or is it somewhere where they subscribe, or is it already a conversion if they ask for a demo product or they reach out to a sales team? And the decisions you make early on then define what happens in these tables. Then I want to go in a little bit about modeling sessions, because modeling sessions it's very common in digital analytics, and it's used to group sequences of events up into sessions and then aggregate data by sessions. And typically, aggregations will include data on how the user was acquired, where the session started, with like a landing page, or was there a search performed, or maybe some sort of marketing attribution. How long did the session last? What was the session worth? So was there a transaction? Did we make any ad revenue, or were there any conversion events recorded? And lastly, what was the user trying to accomplish in this session? So were they on a journey to buy something, or were they looking for information, or were they comparing different products? There's a number of things that can happen there. The sessions are meant to represent continuous streams on user activity. And in the web, we see that it's commonly defined as a session ending when a period of 30 minutes passes and no events take place, which is a weird thing a little bit. And this also hails back to when I said you need to think critically. So as often the definition of what constitutes a session is very vague, even when you define it upfront. It might not correspond to a meaningful unit of work for a user experience. And there's a little bit of history attached to this, because the definition based on a 30-minute timeout, it came from the 1990s, when that made sense, when users would typically interact with one website at a time. But nowadays we have multiple screens, we have multiple tabs open. I might have one website open on my laptop, I have another website open on my phone, but there's also some email coming in. So as a user, I'm engaged with several tasks simultaneously. So say we're a media company and I'm watching a video on your site, something that's a little longer. If I pause and I do something for 30 minutes, is my session done? if I then come back after 35 minutes or an hour and watch the rest of the movie or documentary I was watching, then in our data model we have 2 different sessions. But for me as a user, I might have answered an email and there was 30 minutes and then went back. So my user journey never ended there. I was still in there. So that's why I said in the beginning, critical thinking is very important, because even if people make the step into data modeling in their own data warehouses, a lot of times they will still go with, okay, we need to look at sessionization, 30 minutes and we're done. So if you are at the beginning of this project, or even if you have something started already, find time to critically think about the data you have and what it means to you, as well as in your industry. For some industries, it might absolutely make sense to have 30-minute timeouts. But if a user typically only interacts with your product for 5 minutes, then is that 30-minute timeout necessary? As well as maybe websites, e-learning websites, where I might spend a lot more time and pause 30 minutes to make notes or to look something up or to quiz myself. So think critically, think about what a session means to you, as well as any other things you might define. But nevertheless, the idea of dividing user activity into discrete blocks of continuous activity is a very useful one. Although in general, I prefer grouping events around the specific goals, like the workflows or units of work we just described. But many people still sessionize their data, and if you do that, there's nothing wrong with it. There's plenty of decisions made on this. But maybe next time you look at it, just think about what this might mean to you, and what alternatives there might be out there. Something you especially see nowadays for mobile games is aggregate data by user by day, which is where you see daily active users as a metric, which might make a lot more sense, especially if it's one of those mobile games where you have to wait a certain time before you can do more actions. Then these sessions, shorter sessions, might not make any time, but a day is something that is the same for all users and has a set pattern there. And then lastly, modeling users. A lot of useful user level data can be gleaned by aggregating over a user's entire event stream. For example, based on their entire history, we might bucket them into 2 different cohorts based on how they were acquired or where they were acquired, as well as categorize users into different behavioral segments. Are they a high spender? Are they a low spender? Have they been with us for a long time? Have they just been activated, and are they displaying initial behaviors that might lead to something more? But we can also calculate actual and predicted lifetime value for individual users based on what we know of others, as well as tying particular classes of events in a user journey together to understand the impact of earlier events on later events, which you can combine again with the workflow data we saw earlier. Sorry, and in all the examples I just gave, we're combining a series of events that occur for individual users by grouping them in different ways that summarize continuous streams of activities. And again, you'll be looking at macro events, or looking at workflows and maybe sessions, as well as complete user journeys you might have set out earlier. Often, however, we're particularly interested in specific classes of events and want to understand the impact that one class of events has on the likelihood of something else happening later in the journey, regardless of what might have happened in between. And a common example of this is attribution modeling. And there's a large set of attribution models that are fed data that describes what marketing channels a user has interacted with, a first class of events, maybe early in the user journey, on whether or not the user subsequently converted. So if you were to model this, that looks like this. So we have our user journey. They visit our site through some of that. They click around, maybe they leave, maybe they go away for a couple of days or hours. They see another ad, click on it, go back to our site, and at some point in whatever how many repetitions this needs, the user will convert. And there's a number of ways that we can model this data. Many approaches require the format shown here, where we aggregated a continuous stream of user activity from a first marketing touch forwards, including any details about any subsequent marketing touches and conversion events that took place. And once the data has been aggregated, as you can see here, it's pretty straightforward to one, measure the impact of a marketing channel on the likelihood that a user converts. So we can compare conversion rates for users who've interacted with ad number one with those who have interacted with, who've seen ad number two, to see what the incremental impact of interaction is on the conversion rate. As well as apply a traditional attribution model. So you credit the different marketing touches upstream of a conversation that or conversion that had some sort of value in the downstream, and perform our analysis based on that. So that was a lot of information. Let me wrap up the two different things I discussed here. Data modeling, like I said, is the process of using business logic to aggregate and otherwise transform raw data. So if we properly set up our tracking, we will have a huge batch of very informational raw data, which is hard to use in itself. But then we define what we need from there, and we transform it into model tables that are unique and specific to our business or our use case. And why would you do that? Like I said, things are custom to your business case. So you have defined what you need. You know which calculations you need. You know where your business opinions come in. So we spent some time talking about sessions. What does a session mean to you and your business? Also, you'll be working from one sort of source of truth. You'll have that big amount of anatomic data where all your business teams can look at and pick out what they need. And again, you'll be working on your own definitions, which empower you to make the right decisions for your business. And lastly, we spend a little time talking about how you do that. But very, very important parts being done up front. So define your business rules, define your logic, see where your opinion has to be inserted into the raw data and into raw calculations. Then once you have that set, define your use case. What data is needed, which questions need to be answered, and which teams need that data, and how do they interact with it. So and once you have that set down, you pick your aggregation methods. So are you looking at specific user journeys? Are you looking at sessions, or are you looking at a specific funnel, or are you looking at different groups of users, or do you want to make a marketing attribution model? So those are very important things to think about. But from what I've seen, this is a very successful way of thinking about data modeling, as well as defining and using your data model later on. And like I said in the beginning, all of this comes down to critical thinking, to not be afraid to do something different than you've always done it, to sit down, to discuss what is necessary, and and work from there. So yeah, that is the how and why of data modeling, and specifically in cloud data, where